Hello, in this video, definition of derivative part 2, we're going to look at some more examples of the derivative and try to get our heads around a little bit more of the nuances of when something is differentiable and when it's not. So as an example, just to recap from last time, let's say we have the function fx equals 2x plus 1 over x plus 3. Let's find the derivative, state the interval where it exists. So we use the three-step method. Step 1. We go ahead and calculate f of x plus h. So that'll be 2x plus h plus 1 over x plus h plus 3. That'll give 2x plus 2h plus 1 over x plus h plus 3. Now there's nothing else we can do to simplify, so we'll leave it like that. Step 2 is calculate f of x plus h minus f of x. So we rewrite what we have, 2x plus 2h plus 1 over x plus h plus 3 minus 2x plus 1 over x plus 3. Now initially it doesn't look like we can simplify anything because these are both on different denominators. But we want to maybe find a way for this 2x and this 2x to cancel, or this 1 and this 1. And so we can do a little bit more work. And in particular, we want to simplify this by combining them. We want to use our classic technique of common denominators to get this as one big fraction. So here we're going to have to multiply by x plus h plus 3. X plus h plus 3 on the top and bottom. And over here on this guy, we're going to have to multiply by x plus 3. And then again, x plus 3. So that will give, well, 2x plus 2h plus 1 times x plus 3 minus 2x plus 1 times x plus h plus 3 all over x plus h plus 3 times x plus 3. Now we're not going to go ahead and expand the bottom. This is again a common technique when we're doing calculus. We want to expand the top because that's where we want to have the cancellation. We're just going to leave the bottom factored for right now. So let's go ahead and expand this portion and expand this portion and see what we get. So move this over to make a little more space. Here we go. So 2x times x will be 2x squared. 2x times 3 will be 6x. 2xh. And then 6h. Then an x and then a 3. So that's expanding the first section here. Expanding this gives us the following. Now we have to do the same thing with the second section, and notice there's a negative sign here. So each one of those terms as they come out is going to be negative. So we're going to get negative 2x squared, negative 2xh, negative 6x. And we really have to keep going because now we have to expand in that 1. So negative x, negative h, negative 3. And this is still all over x plus h plus 3 times x plus 3. My goodness, there's a lot of terms there. But again, things are going to cancel. This is going to be good. Hopefully you can see the 2x squared is a clear cancellation right away. And then you just have to go through them piece by piece. It looks like the 6x has a partner over here to cancel. Looks like the 2xh cancels over here. It looks like the x cancels with a negative x. And we've even got a 3 with a negative 3, so I'm going to use a triple slash here on this one. Triple slash with that negative 3. So what we're left with after we clean up all of this craziness is just, well, there's a 6h and there's a minus h. And that's all that's left after all that cancellation. It actually cleans up quite nicely. We could even simplify the 6h minus h to just 5h over x plus h plus 3 times x plus 3. So there we go. We've got a nice simple version, and we're going to go ahead and jump into step number 3. So for step 3, we do the limit h approaching 0 of f of x plus h minus f of x over h. In our case, that'll be the limit h approaches 0 of 5h over x plus h plus 3 times x plus 3. And then we have to put the whole thing over h, so there's like a fraction in our fraction. Now, I'll do this on the side just to make sure we all get the idea here, but the h's are going to cancel, and I'll show you why. What we have is 5h over x plus h plus 3 times x plus 3. And we are dividing by h. This big line here, it means divide. Well, when we divide fractions, what we have to do, again, you can think of this as h over 1. When you're dividing this, is you have to flip and multiply. So you have 5h over x plus h plus 3 times x plus 3 times 1 over h. And so clearly the h's cancel out. You don't have to show that every time, as long as you understand that when you have this and you're dividing by h, you can cancel whatever is in here with the numerator up here. All right, so let's take a look at what we have. The limit h approaches 0 of 5 over x plus h plus 3 times x plus 3. Well, it looks like a good time to plug it in because there's going to be some values that are not all just zeros. We're going to get 5 over, well, x plus 0 plus 3, and then x plus 3, which if we wanted, we could write as 5 over x plus 3 squared. And this is f prime x. So again, we've been able to find our derivative. We could list the interval. So for this one, it'll be true on the interval. Well, we can't have x being equal to -3 because that would make the denominator 0. But everything else is good. So it's negative infinity to -3, union -3 to infinity. There we go. We have our answer for the derivative and, of course, the interval that goes along with it. Now, let's see if we go back to the original function. All the way up here. We had fx as 2x plus 1 over x plus 3. We had f prime x as 5 over x plus 3 squared. And I would ask us to consider, is there some kind of connection? Is there some kind of relationship, pattern between these two? And again, hopefully you see clearly the x plus 3 is the same. But why is it squared? What happened to the 2x plus 1? Why is there a 5? Maybe 2 plus 3 is 5, but what about this 1 over here? Maybe the 2 makes it squared. It's not entirely clear what the connection is, but hopefully you should feel like there's some type of connection. The x plus 3 clearly makes it feel like there's some kind of relationship, but we're not sure what that relationship is. Now again, just to finish this off, we could use the derivative to find the equation of the tangent line. So let's find the equation of the tangent line at 2f of 2. So we need a point, and we have x equal to 2, so that means f of 2 will be 2 times 2 plus 1 over 2 plus 3. That'll give us 5 over 5, which is just 1. So our point is 2 and 1. And then we need a slope. Well, to find our slope, we just do m equal to f prime of 2. We know f prime from the previous page, so it's going to be 5 over 2 plus 3 squared. So 5 over 5 squared. So 5 over 25, which is just 1 over 5. Y minus y1, which is 1, equals m, 1/5, x minus x1, which is 2. And there is our equation of the tangent line. Let's go ahead and try an example with a square root. So here f of x is equal to square root of 2x plus 3, and we're going to find f prime x, and of course its domain. So step 1, we calculated f of x plus h, which will be equal to root 2x plus h plus 3. So we expand that as 2x plus 2h plus 3. Next, we do f of x plus h minus fx, which is going to be equal to root 2x plus 2h plus 3 minus root 2x plus 3. Now, unfortunately, there's nothing we can really simplify here, so the simplification will have to happen sometime in step 3. So we'll go ahead and jump right to step 3. The limit as h approaches 0 of f of x plus h minus fx over h, which will be equal to the limit h approaches 0 of root 2x plus 2h plus 3 minus root 2x plus 3 all over h. Now again, if you were to plug in h equals 0, this would just give you 2x plus 3 under the root, and 2x plus 3, so that'll cancel out to 0. 0 over 0, we need to do more work. And I think it's pretty obvious because we have a root and another root. And when you have two roots, well, you use your technique of rationalization. So we're going to rationalize here. Multiply by the conjugate. Here we'll have root 2x plus 2h plus 3 plus root 2x plus 3. And we do that to both the top and the bottom of the fraction. So we get, well again, when you do the rationalizing, you only multiply out the one you're actually rationalizing. The other portion you just leave. So the bottom we're not going to multiply, we're just going to leave it as h times this thing. On the top, remember the square root's going to disappear from this one and from this one, and the middle terms cancel. So you're just left with 2x plus 2h plus 3 minus 2x plus 3. Now be very careful here, it's minus the whole 2x plus 3. You need to include those brackets. If you don't, we're going to get the wrong answer, and so you just got to make sure that when you're doing this here, the negative has to go and then be part of both of the terms. You could either distribute it right away as negative 2x subtract 3, or put brackets so you know the negative has to apply to both. In the bottom, we're going to have h times 2x plus 2h plus 3 plus root 2x plus 3. And of course, something should cancel. Well, there's a 2x here and a 2x here, and there's a 3 and a 3. Because again, that'll be a negative 3 when you distribute the negative. Okay, well, let's simplify and see what we got. We have the limit, h approaches 0, of 2h over h, root 2x plus 2h plus 3, plus root 2x plus 3. We can cancel out the h's. So we have the limit h approaches 0 of 2 over root 2x plus 2h plus 3 plus root 2x plus 3. Well, it looks like time for us to go ahead and plug it in. We're going to plug in h equal to 0 and see what we get. This will be 2 over root 2x, the 2h goes away, so plus 3, plus root 2x plus 3. Now, we can actually simplify this to make it look a little nicer, so we'll do that over here. If we have 2x plus 3 under a root and another 2x plus 3 under a root, we have two of them. So we have 2x plus 3 under the root. We can cancel out those 2's and give us just 1 over root 2x plus 3. And this is our f prime of x. There we go. We found the derivative. Now we also need the domain, which is a little tricky. For doing a square root, of course, we don't want to have any negative numbers. And for doing a reciprocal, we don't want to have anything of 0 on the bottom. So what that means is we want the 2x plus 3, we want that to be strictly positive, because we don't want it to be equal to 0. Then we would have, of course, a 0 in the bottom, and you don't want it to be negative, or you'd try to square root a negative, which is also bad. So 2x must be greater than negative 3, or x must be greater than negative 3 over 2. So the interval then, written in interval notation, would be negative 3 over 2 to infinity. Another way of saying that is this is the domain. So this is the domain of this function, f prime x. You could think of it like a function because it is a function. It has a formula here. And so it has an associated domain. Now let's go again and look for that connection. So we'll go back to our original function. F of x was equal to root 2x plus 3. And f prime of x is equal to 1 over root 2x plus 3. And again, we're asking ourselves, is there some kind of connection? Well, certainly there's something going on because you've got a root 2x plus 3 and you've got a root 2x plus 3. But here it starts off on the top and here we have a reciprocal. So why is there a reciprocal? And what happens to the 2x plus 3? Does that just stay inside of the square root? Why is the root on the bottom? It feels again like there is a connection, but again, it's not clear exactly what that connection is. Now let's go ahead and do another example here. We're going to look at the following function. F of x is equal to the square root of x. We're going to find f prime x and show that fx is not differentiable at 0. In other words, we're going to show that the derivative doesn't exist or the derivative is not defined. So this is another root example. It's very similar to the other one. We start off with x plus h, which gives us square root x plus h. Number 2, we do f of x plus h minus f of x, which is root x plus h minus root x. And then we go ahead and do the limit as h approaches 0 of fx plus h minus fx over h. So the limit h approaches 0 of root x plus h minus root x over h. Again, if you were to plug this in, you'd get root x minus root x over 0. So this is 0 over 0. We have to do more work, and we should probably do some rationalization. So I encourage you to pause the video now and see if you can come up with the answer. See if you can rationalize, solve the limit, and see if you can get the final answer. Well, hopefully you gave it a try. Let's see if you got the same as me. So x plus h plus root x, then root x plus h plus root x. That's going to be our rationalization. That will give us the limit as h approaches 0 of x plus h minus x over h, root x plus h plus root x. The x's here are going to cancel. So we'll have the limit h approaches 0 of h over h, root x plus h plus root x. The h's are going to cancel. Remember, when nothing is left on the top of a fraction, you always still have a 1. So you've got limit h approaches 0 of 1 over root x plus h plus root x. And it's time to go ahead and limit that. So that'll give 1 over root x plus root x, which is equal to 1 over 2 root x. And so in this case, we have the derivative. The domain is going to be, well, it can't be negative numbers, and if x was 0, you divide by 0. So the domain is from 0 to infinity. And we should see very clearly that since f prime of 0, if you tried to plug in 0 here for x, it's not defined, it's not part of the domain. So since f prime of 0 is undefined, we can say in English, f of x is not differentiable. Not differentiable at x equal to 0. So either having an undefined derivative or being not differentiable, it means the same thing. Now again, let's go back and look here at what we had for our function. F of x was root x. F prime x was equal to 1 over 2 root x. Again, you should see some type of connection. But if you had guessed based on the previous result, the one we did above, it looked like the derivative of the square root was just 1 over that square root. If you had guessed, you might have had a guess like this. You might have said, oh, I'm just going to guess at this. I don't want to do all this work. I'm going to guess that the derivative is just 1 over root x. And you would have been wrong with your guess because you wouldn't have had this 2 there. So where in the world does that 2 come from, and why isn't the 2 on the other one? Again, we're starting to make some progress in terms of building connections, but we're still not there yet. We still have some uncertainty. It's still not clear what the connections and patterns are. So go ahead and try this multiple choice question. You can either take a guess at it or you can work on the limit. Either way, determine the derivative of x squared. So pause the video and give this one a try. All right, so if you work it out, this is actually the question we did in the very first video, where we found the tangent lines, if you remember, for the parabola. It's going to give you 2x. The derivative of x squared will be 2x. So for homework, you can try some questions on page 148, 5 to 11, 21, 31 to 37, and 39. Hopefully you enjoyed this video, and as always, thanks for watching.